we're gonna put this data on the model year of the car you own or you drive.
Where do we put it at?
And you're going to need it. Whoa, dude, what happened to all my software? No. Pause in a moment. Okay, so yes, you're going to need. You want to enter data. You always put data in a list and spreadsheet. So yes, we're going to put in a list here. And you all are going to tell me these numbers real fast. So I'm going to put here. All right.
I need them back.
If you do not have an instant response for me, I'm skipping you. All right. Isaac, you're in your car.
No, but
Okay, Taylor.
2005.
You passed 9. Yeah, you're on way too fast.
2010.
Okay, Josh.
90.
1990.
2002. Oh God, that's too fast.
I don't think I get the first one.
Yeah, I'm like shit. What was it?
Sorry.
87.
It's not
94. 9.
99.
95. Hey, you know what you're doing? I don't know.
Okay.
Go back up. I'm not the top league. Like number 4.
Okay.
I'm number 5. So
You go up to 1.
So there's the first 5. We need to pause it while you guys are typing.
5.
Okay. So once you type the data in, we want to make a histogram. What kind of page do you suppose we need to make if we want to graph it?
Plus.
How do you make scatter plots? They graph data too.
Got it.
You got to make a data and statistics page. So we are going control new page. I thought I was going new page. Then I did get it. Oh, that's because I'm hitting the wrong thing. Duh. Okay. So you're going to go do a number 4 or number 5, excuse me. A data and statistics page. Okay, but in this case,
Whoa, wait.
how do we set it up? You know how to get to that kind of page. Okay, do I have an X and a Y coordinate this time? No, I don't. So, yeah, what do I do here? Just the bottom one? We only have one variable, we just have year.
Yeah, that's just all you do.
Okay. So, if you put that on here, that's actually what we would call a line plot. It's plotting the points on a line. I would like it to actually turn it into a histogram though, with bars. So we need to tell it to change to a histogram. You would guess you would go to menu. Well, okay, there's plot type, that's an option. And there we go. Plot type, histogram. And it
What's wrong with mine? Mine says no list in this problem.
Did you name your data? Did you type year at the top of your spreadsheet? You have to have a name on your data. So if you're looking at this, you should be going, but the bars are split over numbers and this isn't lined up right. Plus, is it really helpful? Did we really want this done by every single year? Or would we maybe want to group them? And yeah, I want to go back and group them and tell it to group some of them together. So do you want to group them by every 5 years, by every 2 years, every 4 years? What would you like to group them by?
Every 5.
4?
8. 32. 12.
5 is probably too much. How many vote for How many vote for 2? How many vote for 3? How many vote for 4?
I like 4.
3, 1. We're going by every 3 years. Okay. Okay, we know our lowest piece of data was 1987. What year do you actually want to start it on? 1985. That's a good one. Okay, we'll start on 85. Okay, so this is just like changing the window on a graph. So where do you suppose we go? Menu. Window. Window settings. Okay, so it's actually set to start on 1985. Okay, it'll take maximum. It doesn't know yet that we want to count these by 3s. So You'd have, in this case, since we're doing threes, which is kind of weird. 1985 plus 30 years would be 2015. So every 3 years would be 2000. We probably should go 2015. So it doesn't. We don't have to break a bar and peak and apart. And then, okay, Y max is how many. This is a guess. How many you think might fall in one bar? How high do we need this Y coordinate to go? 5 or 6? Got a preference?
5. No, 5. 5. Matter.
Fine, we'll try 5. It's okay. Now, is it going to group by every 3 years? Did we do anything there that says group by every 3 years? No, we didn't. You do have to set this. So that got the scaling the way we want it, but we also have to go change something else which is a little bit buried. Alright, we'll try plot properties. Histogram properties.
Wow.
And it's called the bin setting. Each of those little bar groups that we make are called bins. Each bar is a bin. So we are changing bin settings. You could set equal bin or variable bin. We want equal bin, but that doesn't still let us say, hey, dude, do it every 3 years. And we don't want histogram scale either. Why are we not getting? We should be equal bin width. Should be able, yeah, width. So equal bin width, and we want them to be 3s. Starting at 1985.
Even a fatter.
Well, yeah, but there's not as many bars.
Would you go to the list?
Now, okay, what makes that not easy to read?
Like the line with the thing going.
Yeah, okay, so we like to control.
How is that not
Also, the years are really weird.
So, if we went back to window settings, oh shoot, it didn't give us that choice. It used to let me set the scale. That's right, I forgot this with last year. It used to be you could set the scale on the x-axis and you could make it put the tick marks where you want. So yeah, that's not exceptional
histogram scale?
at this point. Where'd you see histogram scale? Back in.
What will be?
That's whether we're on. Well, actually, it's supposed to be frequency. It's not giving me a choice to do frequency. Why isn't it giving me a choice? It is frequency. Yeah, we're supposed to be on frequency. That's normal. So that isn't what we want. So that was one of the things I wasn't real thrilled about with the histograms, is that it doesn't let you quite have as much control. On the old calculators, we could say scale the x-axis in a certain way.
How would they take that away?
I don't know. I've been questioning that myself, why they would take that away. Why we can't control the scaling. There's a few weird things on these that I'm like, why did they do that? So I don't have a total answer. But you can make histogram, print it out, and see how well your data is organized. Now, how do you see how many are in each bar? And what if I want to know this tall bar, how many points go in that tall bar? Well, since we're only 4 high, but you can also click a bar, and it will tell you that bar is running from 1990 to 2002, and it's got 4 data points in it. So if you click on any bar, it'll tell you exactly what it runs between. Okay. Histograms are a really quick and easy way to organize your data and see how it's packed or not. Those histograms are going to be really important for us, particularly when we get to that normal distribution. It's built off of histograms. Okay, in this case, would you call this one center patch when it's kind of off to one side? When the high point's off to one side, we call it skewed. And if I draw you, let me draw you if you get a histogram that does this, if it does something like that, is that centered? That is called skewed. And okay, now let's call it skewed to the right or the left. Anyone to guess which one this is?
Right. Left.
Okay, to me, I always wanted to call it skewed to the left because there's more data on the left. But that's wrong. It's where the tail's going. Where the tail of the data is going, the tail is going to the right, so they say skewed to the right. If your tail goes right. If the tail is on the left side, then it's skewed to the left. Okay, so that's pretty simple. Alright, pause those. our biggest topic of the day is we have to discover how does one find what are known as the measures of central tendency. Okay, this is actually the statistical term for it. What does the word central tendency make you think? I want to measure the what? The middle. These are all ways we can find the middle of a set of data. You have known these for years. There are three. Mean, median, and mode, yes. The measures of central tendency. They find the center of the data. Now, I'm putting center in quotes because it doesn't necessarily mean it's always the middle number. There's some different ways to describe the center of the data. You, yes, already know mean. All right, who can tell me how one calculates a mean? And what's the layman's term for the word mean? The average, yeah. You first learn to calculate averages, but in the world of mathematics and definitely in statistics, you call it a mean. You don't call it an average. It is not mean, though. That's the point. So, it's the sum of the data divided by what? Yeah. I'm going to say the number of items. So you total up all the data and you divide by how many you had. Now, part of when I teach stats, algebra 2, I add more to stats and pre-calc. Stats is becoming a major requirement in tons of college majors. It's almost one of the standard classes. Most majors have to have one stat class. The biggest problem people have with stats is the terminology and the weird symbols. And so my goal is to get you to start learning to read statistical symbols. So I'm going to write, if you went into a stat book, this is what the formula would look like for calculating mean. They would write it in symbols. They would not write it out in words. And it would look like this. It would have this funky Greek letter. It'll look like that. Okay. We talked about it. If you've done Excel and done spreadsheets, you click on that button when you want it to do what? AutoSum. Okay. That's because in mathematics, that's the Greek letter sigma. It's capital S in the Greek alphabet. But the Greek letter sigma always means sum. In math, you see that symbol? We're summing something up. And that's Greek letter sigma, yeah, that's because it's the Greek alphabet. This is capital S. Okay, so that's always sum. X always represents your data. When they write X, that means put the data in. Each piece of data. And then N is always the number of items you have. How many pieces of data? You have 10 sets of numbers, 10 numbers, 50 numbers, whatever. So if you learn to read the symbols, it's no big deal. But people who've never seen stats before, you walk into stat class and suddenly you're thrown at all these symbols. It's like, well, I don't know what to do with them. People freak. Not a big deal. Now, the other thing you need to be more aware of than what you've ever done with stats before, there's a big difference when we're talking about stats, whether we're talking about we've collected this data from a sample or whether we've collected the data from the entire population. That makes a big difference too. Most of the time, even if we wanted to get all the years of the cars in Seneca, would you want to go out and try to talk to every single person in Seneca and find out what year their car is? No, that would be horrible. We would probably do a sample. We would randomly select 100 people, 500 people, and we would go out and we would sample those, and we'd use that sample to represent what's true of all of Seneca. Now, is a sample always perfectly accurate? Does it always represent the whole population perfectly? No, but we accept that when we use samples. Okay, so in statistics, when we do a mean, there are mathematical symbols for mean. If you're talking about the mean of a sample, they'll use an X with a bar over it. So it's the data with the bar means the mean of all that data. That's the symbol for mean when you're doing samples. When you're doing a population is always Greek letters. That's actually the Greek letter mu. It looks like a U with kind of a long tail on the front of it. It's actually the Greek letter mu. That's always a symbol when you're talking a population. That's mean in a population. So it matters whether you're talking about samples or populations. We get much bigger deal in that in pre-cap than we do here. But I want you to start to recognize there's a difference. Okay, now let's get the other. That's mean, but mean is the most used of the three measures of central tendency. I won't tell you it's the most important, necessarily. Sometimes median is better than mean, but it is probably the one we use the most. The average person who hasn't had a stat class would go to the mean every time. They don't really, people don't think about using the median. But if you were to go check average life expectancy, ask for that. Average life expectancy, at what age do people die? They will use the median age. They will not use the mean age.
Because you could die very young.
Yeah, you can die very young, some die very old. You get, and we're going to discover here in a minute, the mean is way more influenced and thrown off. If you have some wild values, the mean will be thrown off. The median is not thrown off if you have some very high or very low values. So sometimes the median is better. Okay, so how do you find a median? It's technically the middle value, yes. It doesn't get its own symbol. I don't know why, but it doesn't get its own symbol. But you just said the key thing, to find a median, what do you have to do with the data first? Has to be in order. I can't not say that loud. It's just critical. Go sick. So if you're going to do a median, you have to put the data in order. Okay? I'll tell you right now, you are forbidden in this classroom to sit there and cross off from each end of the list until you find the middle. You can be a sophisticated mathematician with a brain who can add and divide by 2. I'll talk to you about that in a second. We are not crossing off anymore. We are not in 2nd grade. I saw my son learn to do the median in 2nd grade when I was visiting one day. Okay, they sat one kid down on each end, and then this kid sat down, and then this kid sat down, and then this kid sat down. That was 2nd graders.
And if there's 2 in the middle, you add them up and divide by 2.
Yes, very good.
Oh, Eric.
Okay, so, whoa, that's still on fat.
So it still involves a little bit of...
So I'm going to give you a set of data, and I'm going to conveniently give you this set of data in order. Okay, and yes, you all could find the middle of that data.
Yep, because they're not numbers. Yep.
Now, there's my question. Why did you want to know if it was an odd or an even number?
Because if you're an odd, you can just X out in the middle ones.
Okay, if it's okay. And I want you to, hopefully you do recognize that right now. If it's an odd number, we have 7 numbers across here. If you start canceling them from each end, they'll pair off, and you'll have the one left in the middle. So if there's an odd amount, it's going to land exactly on the middle number. If you have an even amount of data, what's going to happen? It's going to land between 2 numbers if you have an even amount, and you will have to average those 2, or find the mean of those 2 middle numbers. Okay. Well, if I give you a short little data like this, 7 numbers, really you can't, how do you figure out where the middle of 7 numbers is with that? Well, let's find the mathematical way to do it. There are 7 numbers. What do you get if you divide by 2? 3.5. But we know it's odd amount. It's going to land then, you're going to round up or down? You're going to round up. It's going to be on the 4th number. So that way, when I go give you 285 numbers, which I don't think you want to sit there and cross off 285 numbers, where's the middle one going to be?
Okay, but then why did it count over 100 some number?
Well, that's better than having to cross from each end. So if I divide by 2, that's going to be 142 and a half, so it's going to round up and be the 143rd number will be where the median falls. So how do you do it if there's an even amount of data? Okay, so if I had an even amount, say I had 10 numbers, we'll go even. 10 divided by 2 is going to be 5. So that means it's where, though? Because we know if it's even, it's going to land between 2. Is it going to land between the 4th and 5th or the 5th and 6th? Yeah, because you're going to have 5 on each side. So it's going to land. So when you do this divide by 2, it'll be that one and the next one. It'll be between the 5th and 6th number, you'll find the median. So if it's even, you divide by 2, take that number and the next one. Here's where it'll fall. So if I tell you you have 2,400 numbers in your set of data, where is the median of 2,400 numbers? Divide by 2, so it'll be the 1,200th and the 1,201st. That's where you'll find it. Okay? So my point is we cannot cross off forever. The numbers get too big, you got too much data. Now, I'm probably not going to give you that many, at least not by hand. I might give you them by calculator.
How?
I can send you data with the wireless. I can just send it to your calculator.
And then we just go down all
Yeah, you just have the data there and you can do your thing. Okay, I just ran myself out of space, so I guess I'm going to squeeze this over here. How do you find mode? The mode, what do you mean the most? Yeah. Technically, we call it the most frequent value. It also doesn't get its own symbol, sadly, but it doesn't. Mode's the most frequent. Okay, so it's the one that happens the most. But suppose you had a 7 4 times and a 13 4 times. Then both numbers are the mode. It's called bimodal. You have 2 modes. You can have bimodal. You can even have trimodal. You can have 3 modes if there's 3 modes. No, if it goes more than that, they say no mode.
Whoa.
The most you can have is 3 modes. If you have 4 numbers that are all the same, then there really isn't a mode. There really isn't the most frequent.
Can you give us one of those?
Thank you. That's what, yeah. So.
By the way, you're at 20.
Oh, yikes, thank you. Whoa, dude, didn't need to go that far.